So today's problem is removing stars from a string. So you are given a string S which contains a star. In one operation you can choose a star in S and remove the closest non-star character to its left, as well as remove the star itself. So basically whenever we find a star, we have to remove that star and the previous non-star character to its left. Right, so for example here if I have star C O D star E, so that means that I am traversing from in this direction, and whenever I find out a star I remove the previous one. So here that means that T is gone, right? So if my string is, so that means that when you are moving forward, then when I got this star, this is gone, and when I move to this star I need to take the last E out from the system. So that means that it is hinting me that whenever you get a star, you have to track the previous non-star character, and whenever we have to track something previous, which is something like last in first out, a stack could be a good data structure to use. So that means that if I use a stack and I keep on adding my strings, so for example L, then you have a E, then E, and then T, and the moment I got a star I take this value from the stack, so it is gone. Then next is star, so I take this thing out of the star from the stack. Then we can add C, O, D, and when the star came, E is also gone, and then you have a E. Now you have all the non-string non-star characters on the stack, and then you can pop all the elements from the stack and build the result. That looks simple. Now let's code it. So check for the null, as, and then I am going to create a stack of character. Stack is equal to new stack of character, right? And then I'm going to do for each characters C in S, right? Then if it is star, if C is equal to star, that means that we have to take stuff from the stack. But what if that star is the first character? That means I have to check for and stack dot count is greater than 0. In that case I am going to take my character from the stack dot pop, and then else what we're going to do is that we're going to push to the stack. Okay, now at the end we have to take the stuff from the stack. So while stack dot count is greater than 0, we will to capture the result, let's create a string builder object, and you are going to say sb dot. So one thing to note down, that if I am just keep on appending, I am going to get my string in the reverse order. So basically I have to always insert at my 0th position stack dot pop, and then you return result return sp dot to string run. All right, and then you submit. Taking much longer time. Okay, it beats only 7.41, but it works fine. One thing is that this particular code is actually you're inserting at 0. That means that for every character you are shifting the string by n times. So this code is giving me the n square complexity. How can we fix that? So let's say that how about that if I create simple character array, uh, array is equal to new character, and the length is to be, and we know it is stack dot count, right? And then I am going to create integer index is equal to n minus 1, and while in stack dot count is greater than 0, what I'm going to do is that array of index is equal to stack. So I'm going to copy at the back end, and then you can decrement this value. So basically we are copying it like this. So you have array and I have initialized I is this. So whenever I pop this value, so here E it comes here, and then you decrement index, and then D comes here. So on, right? So now return new string of array, and I'm going to run. Oh, array -1, submit. Okay, now it beats lot of things 100%. That looks good using the stack, but here what I'm thinking is that this can be done without the stack also, because if it is, this problem looks very similar to, remember that earlier we used to have code like right. So for example, like we wanted to remove the characters and we wanted to do in one time frame. So what we used to do is that we, anything that we didn't want, we move it to the end, so that all the string that needed is going to be present only here, and all the string that is not needed goes to the end. Similarly, in here what we can do is, so we have L E E T star star C O D E. So what actually we can do is that we can have two pointers where one is say forward and one is backward, slow actually. So it is slow and then fast. So as long as they are not a star, they move together, slow and F. The moment F reaches to a star, since we have to remove this character, we can decrement the slow pointer, so S gets reduced here. Then we move forward again, and then we got a star, and then we move it back again, and then it is C. So what we are going to do is that now it is, we are going to copy it to this location. So this becomes L E C, then F, so we copy it here, O D E. So this is simple two pointer approach. So let's say I am going to do is again without this uh, so we have slow pointer which is actually 0, fast pointer which is at 0, and length of the array is n is equal to s dot length minus 1. Now the problem here is that in C# the strings are immutable, so we need to create an array. A is equal to, let's make it str to make things simple. Cat A is equal to str dot to char array, and then while fast pointer is less than n, right? Now similarly previously when we did if str of f is equal to star, we have to decrement the slow pointer, right? But minus minus s, but we have to do only when s is less than 0. So if s is less than, if s is greater than 0, then you decrement s, right? And once you have done this set, you increment, move to the next place. Else what we are going to do is that we are going to copy, as we said, right? So we are going to copy it fast to slow position. So a of slow is equal to a of f, and then plus plus s and plus plus f, and return new string. Okay, now we are going to, we have to, so if you look at this array, right? So your fast reached here and slow is here, so we need to copy only this array. So we can do this via array A length 0 and end length will be s, str line 5 str so so this is the mistake, n is equal to str dot length. Alright, that's, please feel free to add your comments below. Thank you, thanks for watching, see you tomorrow.